Okay, so with that, um, we are now ready to talk about hardware and software in our computers, right? So essentially, if you think about it, our computers are made up of hardware and software, right? So let me first define what is hardware and what is software. So anything that you can touch and feel, anything tangible in the computer, that is hardware. So for example, your keyboard, mouse, the screen. Also, if your CPU, if it was out of the box, you would be able to touch and feel it, right? So that's also hardware. Now, everything else related to algorithms, the application programs, the software, the data, all of this is software. Okay, you cannot touch and feel them, but they are very much required to make our computers function. So this is basically a simple distinction between hardware and software. Now, an interesting question is, what is the where is the line between hardware and software? So several decades ago, when the computers were still being just beginning to develop, at that point, this boundary between hardware and software was very clear. So basically, there were just two things in the computer. There were these electronic circuits that were required to execute the programs, and then there was this actual program which was running on the hardware. Okay, but over time, as more and more layers were added, removed, and merged, this boundary has become more and more blurred. So the question is, how do we figure out the boundary between the hardware and software, and is there anything that can only be implemented in hardware, and is there anything that can only be done in software? So in fact, an interesting answer, a very interesting answer to this question is, and it is also one of the central themes of this course, and that is, the hardware and software, they are actually equivalent. So essentially, anything that you can code in software, you can also implement it in hardware once you understand it well enough. And similarly, anything that you have implemented in hardware, it can actually be uh, simulated in software. So hardware and software, they are actually really equivalent from that perspective. And this basically brings us to the second question on the class worksheet, which is, if hardware and software, they are equivalent, then how do we decide that a certain functionality should be implemented in hardware or software? Okay, so once again, so essentially, as we have seen, the hardware and software are equivalent. So whatever you can do in hardware can be simulated in software and vice versa. So given that, the way we usually decide if there is a functionality and you have a choice, typically it is decided based on speed and cost. These are the most important factors. So essentially, hardware is almost always faster, but it is also more expensive. In other words, software is almost always cheaper, but also slower than hardware. So essentially, if you have a certain functionality which is critical or crucial to the functioning of your system, so if you have an operation which is going to be used by, let's say, 80% of the users, so it is very important that this operation works fast. In that case, you should implement it in hardware. As opposed to that, if you have a functionality which is, well, which is used by some users, maybe 1 or 2%, but not very many, so you need to support it, you need to provide it, but even if it runs a little slow, it's not very critical to the performance of the overall system. So in that case, you may want to do it cheaper, so you can do it in software. Okay, so typically this decision is almost always done based on speed and cost. For faster implementation, use the hardware, but you will pay the price, you will pay more. For cheaper implementation, use the software, but then it would be slower. Okay, so this is how it is decided.